so in this problem you have a 100 newtons pulling on a 10-meter long steel wire. It gives you the dimensions. The radius is 0.5 millimeters, and the Young's modulus is this value. Calculate how much it will stress. So you recall that you'll see on the formula sheet, that the formula for Young's modulus, where to go? Over here, force over area equals Young's modulus times delta L over L. We're looking for how long it's going to stretch. That is this delta L. L is the original length. So let's put this over here. So our formula sheet is that force over area equals Y delta L over L. How much will it stretch? Okay. We know that the L, let's disconnect some of this material. The original length is 10 meters. The force is 100 newtons. The area we get from this, pi r squared, and Young's modulus is 20 times 10 to the 10th newtons per meter squared. So let's go ahead and do those computations. Let's see. Okay, so force, I have the Olympics on in the background, equals Y delta L over L. We're solving for delta L. That goes to F over A times L over Y is delta L. The trick here will be to watch the units. Okay, so delta L is equal to 100 newtons over the area, pi times the radius, 0.5 millimeters squared. I need to convert that, of course, to meters, times 10 to the third millimeters per meter, and I'm going to square that, times the original length, 10 meters, divided by 20 times 10 to the 10th newtons per meter squared. Okay, so this is the assumption behind this. The assumption is elastic stretching, and I don't know if that's going to happen at all, but we can't check it. We're going to do it. That's where this equation comes from, an elastic stretch. So the delta L, here, let's go ahead and work with the units. We're going to have meters, newtons over here, it's crossing out. Meters squared here, we'll go with meters squared, millimeters squared here. Meter squared here goes with meter squared here. We're left with meters, so let's go ahead and compute this. 100, 10 squared times 10 to the third squared to the sixth times 10 divided by pi squared. I think this is, no, that's 20. Pi times 0.5 squared times 20 times 10 to the 10th. That will be meters. So what do we have? Let's simplify some of the math here. We have 10, 2, 8, 9 divided by 10 is 10 to the negative 1 on top. Or another way of saying that is pi times, I guess, 0.5 times 0.5 is 0.25. And we have 200 on the bottom to simplify all this other stuff. Meters. Okay, so compute that, and you should simplify this value.